Hello guys, welcome back to my YouTube channel. Today I am going to solve day 25 problem of this month on Leetcode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. So today I am going to solve problem number 1038, that is binary search tree to greater sum tree. Okay, so before starting this problem, let's read about what is binary search tree. Okay, so a binary search tree is a tree that satisfies three constraints. Okay, one constraint is that the left subtree of a node contains only nodes with keys less than the node's key. Okay, and the right subtree of a node contains only nodes with keys greater than the node's key. Okay, and both the left and right subtrees must also be binary search tree. Okay, so now here in this example, just forget about these blue color values. Okay, 30, 21. Okay, just forget about these blue color values. Okay, so see, this node value is 4, right? So all the nodes which are in right side of this 4 have greater value than this 4. See, this value 6, 5, 7, 8. Okay, all the nodes have higher value than my root node in the right side, and all the node values in the left side of this root are having less value than my root. Okay, so this value is 1, 0, 2 and 3. Okay, so this is nothing but my binary search tree, right? Binary search tree. Okay, so now just consider this 6. Okay, just check this 6. So all the nodes which are in left side have a lesser value than my root, and all the nodes which are on the right side of this 6 are having greater value than my 6, right? So this is nothing but my binary search tree. Okay, so I hope that you guys are clear with this explanation of what is binary search tree. Okay, so now let's read what we need to do in this problem. Okay, so we have given the root of a binary search tree and we have to convert it to a greater tree such that every key of the original BST is changed to the original key plus the sum of all keys greater than the original key in BST. Okay, so that's nothing but, see here, this node value is 4 now, right? So what are the nodes which are having greater value than this 4? This 6, 5, 7 and 8. Okay, so if I just perform the addition of all the nodes which are having greater value than my current node, so see what is the result that I am going to get. So I am going to get my result as 30. Okay, so this is how I am getting 30 here. Okay, now see for this 6, what are the nodes which are having greater value than this 6? So first we need to write 6 and then add all the nodes which are having greater value than this 6. Okay, so obviously as I have already explained that all the nodes which are having greater value than 6 are on the right side, right? That's nothing but our binary search tree. Okay, so see here, 6 plus 7 plus 8 is 21. Okay, so I hope that this thing is clear. Okay, so see for this one, for this value 1. Okay, how 36 is coming. So see all the values on the right side of this 1 are greater than this 1, right? So 2 and 3, and these values are also greater than my 1 value, right? 1 value. Okay, so if I just add 1 plus 2 plus 3 and add all this stuff, 4 plus 5 plus 6 plus 7 plus 8. Okay, so you will get the result as 36. Okay, 8 plus 7, 15, 6, 21, 26, 30, 33, 35 and 36. Okay, that is how we are getting the result as 36. Okay, so I hope that you guys are clear. Okay, so the left subtree of a node contains only nodes with keys less than the node's key, and the right subtree of a node contains only the keys with the keys greater than the node keys. Okay, so I hope that you guys are clear with the explanation, right? So this is how we need to calculate the values. Okay, so now let's see how we are going to solve this problem. Okay, so this is my example now. So first let's move to the right side now. Let's move to the right side only. Okay, so first from this 4 I go to this 6, and then from this 6 I move to this 7, and then from this 7 I move to this 8, and from this 8 again move to my right side. Okay, so right now this node is null now, so I have to just return null from here. Okay, so here I just need to create one variable sum, and initially I need to set the value of this sum as 0. Okay, so now since I am returning null from here, so my sum will become sum is equal to sum plus my root dot value. what is my root dot value is 8. Okay, 0 plus 8 is equal to 8, and I have to update the value of this root as 8 now. Okay, so this value is nothing but 8. Okay, so see this value is 8. Okay, so first I am iterating over the right side of my binary search tree. Okay, so in the code part, just do one thing, just move to the right part. Okay, so for that I am just going to call this method bst to gst. Okay, and here I am going to the right side. Okay, root dot right, and okay, after moving to the root dot right side, so if my root value is null, okay, if my root is equal to null, okay, then simply return null. Okay, this is my base case, return null. Okay, and first we are moving to the right side only, moving to the right side only. Okay, so here I have to update my sum as well. Okay, so initially let's take a variable int sum is equal to 0. Okay, and now here just update my sum as sum plus root dot value, root dot val. Okay, and now after that just update my root as well. Okay, so now my root dot value is going to become nothing but sum. Okay, so here I am just iterating over the right side. Okay, so after iterating over the right side, we also need to check in the right side, in the left side as well. Okay, so see, from 8 here I am just returning 8. Okay, I have updated this value 8. Now is here, see, this is nothing, null is here. Okay, so I am going to return to this value. Okay, so here 8 plus 7 is nothing but 15, and here also this is null, so I just need to return. So here I reach. Okay, here I reach, so here value is 21. Okay, so here in this 21, when I move to the left side, so there is one node in left side, so I have to move in left side. Okay, and here I have to, after moving to the left side, I have to add this 21 to this value, right, to this value. Okay, so here just do one thing, here just move to the left side. Okay, bst, again call this method bst to gst, and now here call this root dot left. Okay, root dot left. Okay, so here when I reach here, I am going to check for the right side. Okay, so in the right side there is nothing, null. Okay, so I am going to return, and here in the sum I am going to add sum plus root dot value. So what was my value of sum? 21 plus root dot value is 5, so 26. Okay, so this is how I need to update, and my root dot value is going to update as sum. Okay, and in the end I have to just return the value of my root. Okay, return root. Okay, so I hope that this line is clear. Okay, so now let's run the code and see if there are any code issues. So all the test cases has been accepted. Now let's submit it. So see, our solution is accepted, right? And my time complexity is O(n), right? So I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys on the next video. Thank you. Bye bye.